Welcome back. This is our second lesson talking about circles. And today we're talking about measuring arcs and angles. And this is kind of like the pieces of a pie. So perhaps this comes in handy during your next Thanksgiving dinner. Or maybe not. But anyway, it's cool. So let's dive in. A central angle is an angle whose vertex is at the center of a circle and whose sides are radii. So HEC could be a central angle. GEF could also be a central angle. A central angle separates a circle into two arcs. A minor arc, that's one that's less than half the circle. So GF is a minor arc. And a major arc, which is more than half the circle. So GHF is a major arc. And major arcs are named with 3 points. So actually, we could have also called this one GCF. There's a bunch of properties of central angles and arcs. The sum of the measures of the non-overlapping central angles of a circle is 360 degrees. The measure of a minor arc is less than 180 degrees and is equal to the measure of its central angle. So in this case, the measure of GEF, that central angle, equals the measure of its arc, GF. The measure of a major arc is 360 degrees minus the measure of the minor arc. So in this case, the measure of the arc GHF equals 360 minus the measure of the arc GF. The measure of a semicircle is 180 degrees. Two minor arcs are congruent if and only if their corresponding central angles are congruent. So for example, AQB and DQC, if they're both 60 degrees, that means that the arc AB is congruent to the arc DC. And the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. This is called the arc addition postulate. And basically it means if I take ED and I add DC to it, I get the arc EC. So in this example, AC and DB are diameters of circle Q. We're going to identify each arc as a major arc, a minor arc, or a semicircle of the circle, and then we'll find its measure. So let's just do some investigative work here for a second and see what we know. We know that this angle is 100. And we know that the measure of a semicircle is 180. So using that, I can find the measure of BQA to be 80 degrees. I see another semicircle here, which means if I take 180 minus 80 minus 50, I know that AQE is 50 degrees. And finally, across from this angle 80 is a vertical angle, so I know that this angle is also 80 degrees. So with all that, now I can fill in some more missing information. Let's find the measure of arc AE. Well, I know the measure of an arc is less than 180 degrees and equal to the measure of its central angle. Well, its central angle is 50 degrees. So AE is a minor arc measuring 50. The measure of arc AB, well, its central angle is 80. So AB is also a minor arc, and it has a measure of 80. Now, EDC, that central angle is combined from 50 and 80, so that's 130. That's also a minor arc, and its measure is 130. ADC, that's a semicircle, measure 180. ABC, also a semicircle with a measure of 180. And BC, its central angle is 100 degrees, so it's a minor arc of 100. Now we're going to use the circle Z to find each arc length, round to the nearest hundredth. Now to find the length, we need a new formula. And the formula looks like this. L equals x divided by 360 times 2 pi r. Now 2 pi r, that's the circumference of a circle. And the beginning part of the formula, x over 360, gives us what portion of the circle we're interested in. So I need to find the measure of arc QPT if QZ is 10 inches. So QZ is the radius, and we know it's 10. So I can find the circumference of the circle by saying circumference equals 2 times pi times 10, which is about 62.83. Now, to find the measure of the arc length, I need to find the measure of its central angle. I know part of it is 90, but what's this other missing part here? Well, that other missing part is part of a semicircle. So I can take 180 minus 60 minus 90, and I know that missing angle is 30 degrees. So our central angle is now 30 plus 90, which is 120. That goes at the beginning part of the formula. So the length equals 120 over 360 times 6283. Plug all that into the calculator, and you know that the length of arc QPT is 20.94. Let's try another one. We're going to find PQR if TR is 15 meters. Let's start with the central angle first this time. So the central angle is 90 plus 60, so that goes at the beginning of the formula, 150 over 360. Now we need to find the 2 pi r part. Well, 15 meters this time is the diameter, which means the radius is 7.5. So we can replace the r in our formula with 7.5, plug all that into the calculator, and you get the length equals 19.63 meters. Well, so maybe it won't help you at Thanksgiving, but it certainly is interesting. Thanks for being here.